Hello everyone, Trigonometric Identities. In this video, you will learn to simplify trigonometric expressions and to prove trigonometric identities. What is identity? An identity is an equation that always true for every value of the variable. So, if I say x plus x equal to x, this equation is always true for every value of x. But when I say x plus 1 equal to 3, this equation is true when x only equal to 2. So this equation is not identity, but this equation is an identity. Identities enabled us to write the same expression in different ways. When dealing with trigonometric identities, we are going to focus on how best to simplify them into something more manageable. And a lot of times, that thing that's more manageable is a single trigonometric identities. These are some of the trigonometric identities. Simple trigonometric identities, reciprocal identities. Cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tan, sine over cosine, cotan, cosine over sine. And then Pythagorean identities. You have to memorize these identities. Sine square plus cosine square equal to 1. Tan square plus 1 equals secant square. 1 plus cotan square equal cosecant square. Even and odd identities. We know that sine and tan are odd functions, and we know that odd function means f of negative x equal to negative f of x. So sine negative x is negative sine x, tangent negative x is negative tan x. What about odd? What about even function? An even f of negative x equal to f of x. So cosine negative x is cosine x, the same as cosine x. The last group of trigonometric identities you have to memorize cofunction identities, and this depends on complementary angles. As we learned before, if we have right triangle, this is the right angle, so the other two angles are complementary. So theta, and here beta. So theta or beta equal to 90 degrees minus theta. So here we know that this side is opposite to angle beta but adjacent to angle theta. Here hypotenuse. So when I say sine theta, if here we have here A, B, and here C, so sine theta equal to B over C. And what about cosine beta? The same as sine theta, it will be B over C, adjacent over hypotenuse. And we know that beta is 90 minus theta, and we know that 90 degrees is pi over 2 radian. So sine pi over 2 minus x is cosine x, tan pi over 2 minus x is cotangent x, secant pi over 2 minus x is cosecant x, cosine pi over 2 minus x sine x, cotan pi over 2 minus x tan x, cosecant pi over 2 minus x is secant. A lot of times, the best way to simplify a trigonometric expression is by writing everything to be in terms of sine and cosine. So, if there is a trigonometric function and that isn't in terms of sine and cosine, we are going to change it to be in terms of sine and cosine. For example, simplify. Cosine x plus tan x sine x. First, let us determine operations in this expression. Here we have addition, and here we have multiplication, tan multiplied by sine. So tangent can be written as sine over cosine, so that's what I'm gonna do. Keep cosine. Now need to change tan to be sine over cosine, and here we have multiplication times sine x. The next thing I'm going to do is I'm going to multiply these together. So let us multiply. Here, keep cosine, plus, now multiply. Sine means sine over 1, so sine square x over cosine x. To simplify this expression, we have to change denominators to be the same. We can multiply cross product, or you can multiply here by cosine x, and here if you multiply denominator you must multiply numerator. So now the new expression is cosine x in denominator. Now in numerator, cosine square x plus sine square x. And here we have the first Pythagorean identity. Sine square plus cosine square is 1, so 1 over cosine x. And we know that this is another identity, 1 over cosine. We can use reciprocal identities, and 1 over cosine is secant x. That's it. Another example. sine theta over cosine theta plus cosine theta over 1 plus sine theta. We need to simplify this expression. Okay, to simplify this expression, we need to combine the fractions by using common denominator. So here the denominator is cosine theta, and here denominator is an expression 1 plus sine theta. So we need to change all denominators to be the same, so we can do like this. So here we have here cosine theta times 1 plus sine theta, and in numerator we have to multiply sine theta by 1 plus sine theta, here plus cosine theta times cosine theta. Okay, I'm gonna to distribute in numerator, but I leave denominator. Why? Because I have to check if I can simplify numerator with denominator. So sine theta times 1 is sine theta plus sine square theta, and here cosine times cosine is cosine square theta over, keep denominator cosine theta 1 plus sine theta. Now we have Pythagorean identity. Sine square theta plus cosine square theta is 1. So I can rewrite the expression again. Sine theta plus 1 over cosine theta times 1 plus sine theta. And we know that sine theta plus 1 is the same as 1 plus sine theta. So we can simplify the expression sine theta plus 1 plus and the expression in denominator. So we will have 1 over cosine theta, and we know that using reciprocal identities this expression is secant theta. Proving trigonometric identities. Here are guidelines for proving trigonometric identities. First, start with one side. Number 2, use non-identities. Number 3, convert to sines and cosine. For example, prove that cosine theta times secant theta minus cosine theta equal to sine square theta. Here we have two sides, left hand side, and here right hand side. The left hand side looks more complicated, So we start with it and try to transform it into the right hand side. Let us start. Left hand side equal cosine theta times secant theta minus cosine theta. I said we have to convert each trigonometric function in terms of sine and cosine, and we know that secant theta is 1 over cosine theta. Now complete the expression. Cosine theta minus cosine theta. Now we can distribute cosine theta over this expression, so we will have cosine theta times 1 over cosine theta minus cosine theta times cosine theta. Okay, now simplify. Cosine is 1 minus cosine square theta. And you know that 1, the first Pythagorean identity, is sine square theta plus cosine square theta equal to 1 minus cosine square theta, so cancel sine square theta, and this is the right hand side. That's it. Another example. Verify the identity 2 tan x secant x equal to 1 over 1 minus sine x minus 1 over 1 plus cosine 1 plus sine x. So here we have to find a common denominator and combine the fractions on the right hand side. So let us start. Right hand side equal, I write the expression again, 1 over 1 minus sine x minus 1 over 1 plus sine x. Okay, now change denominators to be the same. So we have here same denominator, 1 minus sine x times 1 plus sine x, and here 1 plus sine x times 1 minus 1 times 1 minus sine x. Step by step, don't do it directly, because we have here negative sign. It will change all signs. So 1 plus sine x, distribute negative sign, so minus 1 minus plus sine x over, here we have 1 minus sine x times 1 plus sine x, same expression with opposite operation, so we can multiply it directly and get difference of two squares, so it will be 1 minus sine square x. Now simplify numerator, so sine x plus sine x is 2 sine x, and using Pythagorean identity 1 minus sine square x is cosine square x. In the left hand side we have tangent x and secant x. By logic, sine over cosine is tangent, so we can rewrite this expression again as 2 times sine x over cosine x times cosine x. Now let us rewrite the expression. So here 2, and we know that sine over cosine represent 10, and now 1 over cosine represent secant, the left hand side. That's it. Verify the identity. Cosine x over 1 minus sine x equals secant x plus 10x. Here we have fractional or rational expression, so we can start with the left hand side. So left hand side, cosine x over 1 minus sine x. But now what should I do? So here we have 1 minus sine x in denominator, so we can multiply by its conjugate and introduce something new. So multiply by 1 plus sine x in numerator and denominator, and if we multiply denominator we must multiply numerator. Okay, now let us start to multiply. We have here in numerator cosine x times 1 plus sine x. I'll not distribute till I be sure that there is no common factor in numerator and denominator. So we have here in denominator 1 minus sine x times 1 plus sine x. I said before it's 1 minus sine square x. Using Pythagorean identity, 1 minus sine square x is cosine square x, so we have here cosine x times 1 plus sine x over cosine square x, and we can simplify cosine x with 1 of cosine here, so it will be 1 plus sine x over cosine x. Now we have only one term monomial in denominator, so we can distribute each term here. So is 1 over cosine x plus sine x over cosine x equal to secant x plus 10x using reciprocal identities. You can do it by another way. You can start with the right hand side if you want and change 10 to be sine over cosine and change secant to be 1 over cosine, then take common denominator. You can do it. Try it now. So that's it for this video. Thank you. See you next time. Please like and subscribe.